into the bile ducts to prevent cholestasis with a high concentrate and gradients into the liver. The transportation of bile acid is an important factor that regulates the formation and flow of bile acid. The secretion of bile acid also high affects the secretion of cholesterol and bilirubin into the bile. The osmotic pressure generated by the active transport of bile acid lead to an increase of secretion of water and electrolytes into the bile ducts, therefore increasing the amount of bile flowing through the bile ducts. The bile acid module contains both hydrophilic hydrolysis and carbinox groups, as well as hydrophilic meth groups and hydrocarbon nucleons. Therefore, the main configuration of bile acid have hydrophilic and hydrophobic sites. Makes the module has the characteristics of interphysical active modules. It can reduce the surface tension between the oil and the water phases to promote the emulsification of lipids. The fat is dissolved into the center of bile acid module and is wrapped by the bile acid modules, which reduce the surface tensions of fat, makes the fat emulsification into the droplets, and is disperses in intestines, thus increasing the area of action of pancreatic lipids. It accelerates the effect of breaking down fats. And the bile acid cholesterol features that bile acid provide an important excretion pathway for cholesterol metabolism, and 1/3 of catabolism of cholesterol is achieved through the synthesis of bile acids. The regulation of our cholesterol synthesis in the liver is closely related to the intestinal hepatic circulation of bile acid. The reabsorption of the bile acid has a negative feedback regulation effect on the synthesis of bile acid itself, and therefore also has a negative feedback regulation effect on the decomposition of cholesterol. Bile acid also can regulate the synthesis of intestinal cholesterol. Bile acid plays a coordinate role in the absorption of fat cholesterol. The absorbed cholesterol directly regulates the size of cholesterol in intestinal cells and liver cells. Bile acid can promote the secretion of cholesterol in bile and play an important role in maintaining the solubility of cholesterol. And another way, bile acid can enhance immunity, because it has the functions of improving animal immunity and reduce the absorption of bacteria and toxins in animals. With the extensive use of antibiotics in the aquaculture industry, issues such as resistance in bacteria and the secondary population of antibiotics have received more and more attention. Antibiotics products produce a large amount of antitoxins after killing bacteria, which is called secondary population of antibiotics. Endotoxins seriously affect the health of animals, easily cause acute liver nutrients deficiencies and are not easy to prevent. The lack of bile acid will accelerate the absorption of endotoxin in the animal in the small intestine and produce severe gastric obstruction. If an animal keeps in a poor amount of deoxygenated bile acid, it can effectively decompose and remove endotoxins, prevent the damage of endotoxins to the animal's liver and intestine, and maintain the health of the animal body. Bile acid is an effective bacteria. In the large intestine of animal, bile acid can inhibit the proliferation of stercolis. Bile acid also prevents food from rotting and fermenting in the stomach. Therefore, bile acid can also prevent disease such as bloating and abnormality swelling. Prolong in 2001 studied the anti-inflammatory and antibacterial effects of taurine and cholic acid. The active ingredient of chicken bile caused has no direct antibacterial effect. Cholic acid has obviously antibacterial effect on G+ bacteria. Why we are using the bile acid and what bile acid can help in the animals? For the young animals, we all know that the development of digestive tract is not perfect, and the digestion and absorption of various nutrients is limited. The secretion of bile acid in the body is very slow and very low, which is far from meeting the need of animals' digestive fat. Therefore, exogenous additional bile acid can make up for the deficiency of insufficient secretion of endogenous bile acid in young animals. For the farmed animals in the breeding process, in order to pursue the rapid growth animals, a large amount of oil is often added to the feed, which causes the liver to be too heavy, which affects the growth of conversion of protein, carbohydrates, especially fats. Adding bile acid can improve liver functions and reduce the occurrence of fat diarrhea and overfeeding. For fish, due to its short digestive tracts, often only for one third is its body length. Some herbivorous of omnivorous fish have very little gastrointestinal differentiation, and their digestion and absorption of nutrients is limited. Moreover, the large amount of protein added into the fish feed is often converted into fat and deposited in the liver. If it cannot be transported out in time, it will cause the outbreak, fat liver, and hepatobiliary syndrome. The additional bile acid can promote and excretion of toxins in liver, fat, and effectively prevent fatty liver and hepatobiliary syndrome. For crustaceans and some fish, some carbs and shapes. In the process of its growth, it needs to undergo molting and metamorphosis. The feed needed to add sterols or bile acid. This substance can transform addition in the body, promote its molting growth, and accelerate the metabolic processing of crystals. In summary, the reduction of used bile acid in feed can effectively promote the emulsification, digestion, and absorption of fat, promote biosecretion, protect the liver, and promote cholestatic, improve the health and functions of the liver, promote animals' food intake, improve feeding efficiency, and reduce feed cost, thereby improve the animal performance as a natural fat digestion promoter. The application of bile acid in feed has important, particularly significant and broad prospects.